Hey there, and welcome back. Today we're diving into the absolute chaos that was electrical engineering in the 1960s. We're talking about systems that failed so often, electricians practically lived at people's houses. If you love exploring the disasters of vintage technology, make sure to hit that subscribe button and ring the bell so you never miss out on our deep dives into engineering mayhem. Let's get started with 25 electrical systems from the 60s that were constantly, and I mean constantly, breaking down. First up, we have aluminum wiring, and oh boy, was this a nightmare. During the 60s, copper prices skyrocketed, so brilliant minds decided aluminum would be the perfect substitute for residential wiring. Wrong. Aluminum expands and contracts way more than copper when it heats up and cools down. This meant connections would loosen over time, creating resistance, which created heat, which created fire hazards. Houses were literally burning down because of this cost-cutting measure. The connections would oxidize, become brittle, and fail without warning. Homeowners would wake up to flickering lights one day and an electrical fire the next. Even worse, standard switches and outlets weren't designed for aluminum, making the problem 10 times worse. This disaster lasted well into the 70s before people finally admitted it was a terrible idea. Next, let's talk about knob and tube wiring that was still hanging around in the 60s. Yeah, this system was already ancient by then, dating back to the 1800s, but plenty of homes were still using it. The concept was simple. Ceramic knobs held wires in place, and ceramic tubes protected them through joists. Sounds fine until you realize there's zero grounding, no protection against moisture, and insulation that degraded faster than milk left in the sun. The rubber and cloth insulation would crack, expose bare wires, and create short circuits everywhere. Add in the fact that 60s homeowners were using way more electricity than these systems were designed for, and you've got a recipe for constant failures. Air conditioners, televisions, and kitchen appliances were overloading circuits that were meant for a few light bulbs. Electricians made bank replacing these relics. Third on our list is the early push-button light switches. These were supposed to be the modern, sleek alternative to traditional toggle switches. They looked cool, sure, but the internal mechanisms were absolute garbage. If the buttons would stick, fail to make contact, or just stop working altogether after a few months. The problem was the cheap spring mechanisms and contact points that would corrode or wear out incredibly fast. People would press the button and nothing would happen, or the light would flicker like a haunted house. Some models had such poor manufacturing that the buttons would literally fall into the wall cavity. Homeowners got so frustrated that most ripped them out and went back to regular switches within a year or two. Number 4 is the infamous Federal Pacific Electric panels, also known as FPE panels. These breaker boxes were installed in millions of homes during the 60s, and they had a catastrophic flaw. The breakers often wouldn't trip when they were supposed to. When a circuit overloaded, but instead of cutting power like they should, these breakers would just keep on going, letting wires overheat and start fires. Independent testing later showed that these breakers failed to trip up to 60% of the time. 60%! That's worse than a coin flip. The bus bars inside the panels would also fail, causing loose connections and arcing. Entire houses burned down because these panels couldn't do the one job they were designed for. They're still in some homes today, ticking time bombs waiting for the right overload condition. Coming in at number 5, we have early residential intercom systems. Every fancy house in the 60s wanted one of these built-in communication systems. They were marketed as the height of modern convenience, but they were plagued with problems. The wiring was often undersized and poorly insulated, leading to constant static, buzzing, and complete failures. The transformer units would overheat and burn out regularly. The speaker units would crackle or go silent without warning. Moisture was their worst enemy, and since many were installed near kitchens and bathrooms, condensation would wreak havoc on the electronics. Repair technicians would show up, replace a component, and be back a month later for the same issue. Most homeowners just gave up and started yelling through the house instead. Sixth, let's discuss automatic garage door openers from the 60s. The concept was revolutionary. Push a button and your garage door magically opens. Reality was very different. These early systems used basic electrical motors with chain or screw drives that jammed constantly. The limit switches that told the door when to stop would fail, causing doors to slam down or refuse to close. The reversing mechanisms, meant to stop the door if something was in the way, barely worked or didn't exist at all. Kids and pets were injured because the safety features were basically non-existent. The transmitters were unreliable, working only if you were parked right in front of the garage and sacrificed a chicken to the electronics gods. Rain, cold, or heat would cause the whole system to seize up. People went back to opening doors manually, faster than you can say product recall. Number 7 is the doorbell transformer systems of the era. These seem simple enough, right? A transformer steps down household voltage to power a doorbell. But 60s transformers were cheap, poorly made, and constantly failed. They'd overheat, short out, or just stop providing power. The wiring connections were often exposed and would corrode, especially in humid climates. Homeowners would press the doorbell button and hear nothing, or sometimes a sad, dying buzz. The buttons themselves would stick or crack, and the chimes would stop working because the mechanisms inside would seize up. What should have been a set-it-and-forget-it system turned into a recurring maintenance headache that had electricians shaking their heads. 8th on the list, we have electric baseboard heaters. These became super popular in the 60s as a modern alternative to radiators. They were supposed to be efficient and safe. They were neither. The thermostats were wildly inaccurate, causing rooms to swing between freezing and sweltering. The heating elements would fail constantly, especially if dust accumulated on them, which it always did. The wiring connections would loosen from the constant expansion and contraction, creating fire hazards. Some units would keep heating even when turned off because the relay switches would weld themselves closed from arcing. People woke up to rooms that felt like saunas or heaters that sparked and smoked. The plastic end caps would melt, and the metal housings would get hot enough to cause burns. They were maintenance nightmares that required constant attention. Number 9 brings us to early electric water heaters with their primitive thermostats and heating elements. These appliances were essential but incredibly unreliable in the 60s. The thermostats were basic bimetallic strip designs that would drift out of calibration constantly. You'd set it for a comfortable temperature and get scalding hot water or ice-cold showers. The heating elements would corrode and fail, especially in areas with hard water. Sediment buildup would insulate the elements, making them overheat and burn out. The wiring terminals would loosen and arc, creating fire hazards. The pressure relief valves would stick or leak, and the whole unit would need servicing every few months. Plumbers and electricians worked in tandem to keep these things functional. Number 10 is the whole house attic fan systems. These massive fans were installed in attics to ventilate homes before central air conditioning became common. The motors were loud, inefficient, and broke down constantly. Bearings would seize up from heat and lack of lubrication. The belt drive systems would snap or slip. The thermostatic controls would fail, causing the fan to run non-stop or not at all. And the shutters that were supposed to close automatically when the fan stopped would jam open, letting cold air pour out in winter. The vibrations from these industrial-strength fans would literally shake houses apart, loosening roof shingles and cracking plaster. The electrical draw was enormous, and the wiring would overheat if not properly sized. Most homeowners turned them off and never looked back. Number 11, we need to talk about electric ranges with their failure-prone infinite switch controls. These rotary switches controlled the heat of the burners and were supposed to allow infinite temperature adjustment. In practice, they failed constantly. The contacts inside would pit and corrode, causing erratic heating. You'd turn the dial to medium and get either nothing or full blast. The switches would arc internally, creating burnt smells and sometimes small fires. The spring mechanisms would wear out, and the knobs would just spin freely without controlling anything. Replacement was expensive, and they'd fail again within months. Housewives of the 60s became experts at working around broken burners and unreliable ovens. Coming in at 12, early central air conditioning systems were electrical disasters. The compressors would fail because the starting capacitors and relays were cheaply made. The systems would hum and click but never start, leaving families sweltering in summer heat. The thermostats were primitive and would stick or fail to call for cooling. The blower motors would overheat and seize up. The wiring was often undersized for the massive current draw, causing breakers to trip constantly or wires to overheat. Josh, the contactors that switched the compressor on and off would weld closed or burn out. Freon leaks were common, and the whole system required constant professional service that cost a fortune. Many people gave up and went back to window units. 13 on our countdown is the electric clothes dryer with its temperamental timer mechanisms and heating elements. The timers were complex mechanical devices with dozens of tiny contacts that would corrode, stick, or break. Dryers would run forever or stop after 5 minutes. The heating elements would crack and fail, leaving people with tumbling wet clothes and no heat. The thermostats and thermal fuses would fail, either preventing the dryer from heating or letting it overheat and scorch clothes. The door switches would wear out and the dryer wouldn't run even with the door closed. The motors would overheat because lint would clog the venting, creating fire hazards that burned down homes. These machines required repairs so often that appliance technicians knew families by name. 14. Let's discuss television antenna rotators. As TV became huge in the 60s, people wanted to aim their rooftop antennas for the best reception. Electric rotators were the solution, and they were terrible. The control boxes would fail, the motors would burn out, and the gear mechanisms would strip or freeze. The wiring running up to the roof would degrade from weather exposure, causing intermittent operation. You'd try to rotate the antenna and hear grinding noises or nothing at all. The direction indicators would lie, showing the antenna pointing north when it was actually stuck facing east. Wind and corrosion would seize the rotating mechanism solid. People climbed on roofs in the middle of storms trying to manually adjust these things because the electrical systems were so unreliable. Number 15 brings us to early dishwasher systems. These were luxury items in the 60s, and they spent more time broken than working. The timer mechanisms were complicated and would fail constantly. The door latches had electrical interlocks that would malfunction, preventing the machine from starting. The heating elements would burn out or the thermostats would fail, leaving dishes washed in cold water. The pump motors would seize or the seals would leak, causing water damage and electrical shorts. The spray arm mechanisms would clog, and the whole electrical system would need resetting or repairing. The wiring would corrode from constant moisture exposure. Owning a dishwasher meant having a repair technician on speed dial. 16 on the list is exterior lighting systems with their moisture-prone fixtures and photocell controls. The photocells that were supposed to turn lights on at dusk and off at dawn would fail constantly. They'd get stuck on, stuck off, or cycle randomly throughout the day. Moisture would infiltrate the fixtures, corroding sockets and wiring. The gaskets were inadequate, and water would pool inside, causing shorts and blown bulbs. Ground fault issues were common because proper grounding wasn't standard. The wiring buried in walls or underground would degrade, causing intermittent operation. Homeowners would have lights that worked one day and failed the next, requiring constant bulb and fixture replacement. 17, we have electric lawnmowers, which were supposed to be the quiet, clean alternative to gas mowers. The reality was extension cords everywhere and motors that burned out constantly. The brushes in the motors would wear down quickly and the armatures would short out. The safety switches would fail and the mowers would either not start or not stop. The wiring inside would fray from vibration, creating shock hazards. Cutting the power cord was a constant risk that could electrocute users. The blade engagement mechanisms would fail, leaving you with a running motor but no spinning blade. These things spent half their lives in repair shops. 18. Let's talk about electric can openers, a kitchen staple that failed with impressive regularity. The gears would strip, the cutting wheels would dull and jam, and the magnets that held the can would lose strength. But the electrical failures were special. The motors would burn out from overuse or seize from lack of lubrication. The switches would fail, and the opener would run continuously or not at all. The power cords would fray at the base, creating shock and fire hazards. People would be midway through opening a can when the whole thing would die, leaving them to finish the job with a manual opener. These appliances were so unreliable that most ended up in the trash within a year. 19 on our countdown is the electric blanket, marketed as a cozy necessity but actually a hazard factory. The heating wires inside would break from folding and washing, creating dead zones or hot spots. The thermostatic controls would fail, causing blankets to overheat and burn users or not heat at all. The connections between the blanket and controller would corrode or loosen, causing intermittent operation. The wiring insulation would degrade and people would get shocked when adjusting the blanket. There were numerous reports of electric blankets catching fire during the night. The dual control models for couples would have one side working and one side dead. They required replacement so often that manufacturers made a fortune on repeat sales. 20. We need to discuss early smoke detectors that were being introduced in the 60s. Ionization-type detectors were temperamental and required household current, making them dependent on reliable wiring. The sensors would become contaminated and either trigger false alarms constantly or fail to detect actual smoke. The backup batteries, if they existed, would die and not alert users. And the wiring connections would corrode, rendering the unit useless. The alarm mechanisms would fail, leaving homes unprotected. These early life-saving devices were so unreliable that many people disabled them out of frustration, defeating their entire purpose. Later, battery-operated models were far more dependable. 21 brings us to electric hair dryers, handheld hazards that combined water, electricity, and poor engineering. The heating elements would fail, leaving users with cold air. The motors would overheat and burn out from blocked air vents, usually clogged with hair. The switches would fail in the on position, and dryers would need to be unplugged to turn off. The power cords would fray, especially near the handle, creating serious shock risks. Using these near water was incredibly dangerous. And electrocutions in bathrooms were tragically common before ground fault interrupters became standard. The plastic housings would crack from the heat, exposing internal wiring. These devices were replaced constantly. 22 on the list is the whole house vacuum system. Wealthy homes installed central vacuum systems with outlets in each room connected to a main unit in the basement or garage. The motors were powerful but temperamental, overheating and failing regularly. The electrical controls that activated the system when a hose was plugged in would malfunction. The low-voltage wiring running throughout the house would short or break. The relay systems would fail, leaving the motor running constantly or not at all. Clogs in the tubing would cause the motor to overheat and burn out. The filter systems would fail, and dust would blow back into living spaces. Repair was expensive and complicated, requiring electricians and specialized technicians. 23. Let's discuss electric knife sharpeners that were kitchen gadgets destined to fail. The abrasive wheels would wear unevenly or seize up. The motors were underpowered and would burn out quickly from the friction load. The guide mechanisms would break, and knives would be sharpened at wrong angles or damaged. The switches would fail, and the units would need to be unplugged for safety. The cooling vents would clog with metal dust, causing overheating. The power cords would fray from being wrapped too tightly. These devices promised convenience, but delivered constant frustration and frequent replacement. Most people went back to manual sharpening stones. Us 24 on our countdown is electric fence chargers for rural properties. These were supposed to deliver regular pulses to keep livestock contained. The transformers and capacitors would fail, leaving fences uncharged. The timing circuits would malfunction, delivering irregular pulses or constant current, which could injure animals. Lightning strikes would destroy the units entirely. The grounding systems would corrode, reducing effectiveness. The wiring connections would loosen and arc. Vegetation touching the fence would drain power and overheat the charger. Farmers would constantly troubleshoot and repair these systems to keep their animals secure. Reliability was a fantasy. And finally, 25, we have the electric wall clock, something so simple yet so prone to failure in the 60s. These clocks relied on the 60 Hz frequency of household current to keep time. Any voltage fluctuation would cause them to run fast or slow. The small synchronous motors would fail, and the clocks would stop entirely. The gears would strip or seize from poor lubrication. The electrical contacts would corrode, causing intermittent operation. Power outages meant resetting the time constantly, and there were no battery backups. The illuminated dial lights would burn out and be difficult to replace. These clocks were supposed to be set and forget, but people were constantly adjusting or replacing them. It's amazing how something so basic could be so unreliable. There you have it. 25 electrical systems from the 1960s that kept repair technicians employed and homeowners frustrated. These weren't just minor inconveniences. They were legitimate safety hazards, fire risks, and constant money drains. Engineering has come a long way since then, with better materials, improved safety standards, and more rigorous testing. But looking back at these disasters reminds us that progress often comes through spectacular failure. If you enjoyed this trip down memory lane through electrical chaos, give this video a thumbs up, share it with anyone who loves retro technology disasters, and don't forget to subscribe for more content, diving deep into engineering failures and vintage tech. Drop a comment below if you or your family dealt with any of these nightmares. Thanks for watching, and I'll see you in the next one. The crazy part about all of this is that people adapted. They learned which systems were going to fail and planned accordingly. Homeowners became amateur electricians out of necessity, keeping spare breakers, extra fuses, and backup components on hand like survival supplies. They knew their houses inside and out, understanding exactly which circuits would overload if they ran the air conditioner and the oven simultaneously. They'd schedule their laundry around peak hours to avoid tripping breakers. They kept rotary phones as backups because they didn't require electricity to work. In a way, 60s homeowners were more connected to their homes than people today, understanding every electrical system intimately because they had to troubleshoot problems constantly. What's really interesting is how these failures actually drove innovation. Engineers looked at these disasters and thought, well, we can do better. That frustration and those safety concerns directly led to the development of ground fault interrupters, better circuit breaker technology, improved materials that didn't expand and contract as drastically, and more rigorous safety testing standards. The failures of the 60s became the success stories of the 70s and 80s. Companies started competing on reliability rather than just cutting costs. Insurance companies got involved, demanding safer electrical systems. Building codes evolved to prevent the same problems from happening again. Today, we take electrical reliability almost completely for granted. You flip a switch and light happens. You plug in an appliance and it works. You don't worry that your refrigerator might catch fire or that your water heater might explode. But we owe that peace of mind to all those electricians and engineers who suffered through the 60s and learned hard lessons from every failure. Their frustration and the homeowners' endless problems became the foundation for modern electrical standards that keep us safe. Every time you use an outlet that's properly grounded, every time a circuit breaker trips to prevent a fire, every time a ground fault interrupter stops you from getting electrocuted in a bathroom, you're benefiting from lessons learned through decades of 60s electrical disasters. The documentary evidence from that era is actually fascinating. Fire departments kept detailed records of fires caused by electrical failure. Insurance companies studied patterns to understand risk. Manufacturers eventually faced lawsuits, which finally convinced them that cutting corners wasn't worth the legal liability. Some of these systems became so notorious that they're still discussed in electrical engineering courses as cautionary tales. Federal Pacific Electric panels are still being replaced in homes today, 60 years later, because they're considered too dangerous to leave in place. That's the legacy of poor engineering and cost-cutting decisions. If you're dealing with a home from the 60s right now and you're watching this, maybe some of what we've discussed is familiar. Maybe you've had electricians tell you that your panel needs replacing, or your wiring is outdated and dangerous. They're not trying to upsell you. They're trying to keep you safe. Those old systems were genuinely hazardous, and while they might still be functioning, they're operating on borrowed time. Modern electrical codes exist because people literally died or lost their homes to these failures. It's worth taking seriously if you own a vintage house. Looking at this from a broader perspective, the 60s electrical disaster represents a really important moment in consumer protection history. It's when people started demanding better, when they stopped accepting constant failures as normal. They pushed back, regulators listened, manufacturers adapted, and standards improved. That same cycle happens today with modern technology. We see products that are unreliable, unsafe, or poorly designed, and consumers voice their frustrations. Eventually, that pressure leads to innovation and improvement. Yet the 60s electrical chaos was actually the birth of the modern consumer protection movement in many ways. If you ever find yourself complaining about modern technology, remember that it could be so much worse. Your laptop could randomly catch fire. Your phone charger could electrocute you. Your home's electrical system could be slowly burning itself down while you sleep. The fact that these things don't happen is the result of learning from spectacular failures and choosing to do better. Progress isn't always flashy or exciting, but it's built on the foundation of understanding what went wrong before. Thanks again for hanging out with us through this deep dive into 60s electrical chaos. We hope you learned something about how far we've come and maybe gained some respect for the electrical engineers and technicians who fix these messes. If you found this content interesting, please consider subscribing to the channel because we've got way more stories about technological disasters, engineering failures, and vintage systems that should have never made it to market. Hit that notification bell so you don't miss our next video and leave a comment telling us what you thought about this electrical nightmare tour. Did any of these systems surprise you? What's the oldest electrical system you've encountered? We'd love to hear from you. Thanks for watching, and we'll catch you in the next one.